Okay, ladies and gentlemen, I hope you had a good break, and as already announced, we are now going to have an award session, and we're very excited about that because we talked about different policies for the electronic components and systems industry. We already talked about some projects, and now we're going to focus on some of them that we can rightly coin some pearls within the community. And ladies and gentlemen, the first award that will be handed out is the PENTA Innovation Award. And thereafter we'll discuss with you an ECSEL award and also a Horizon 2020 award. Well, the first one is a part of a PENTA healthcare project named DISPERSE. And DISPERSE started on the 1st of February 2017 and finished on the 31st of January 2020. The project was primarily initiated to develop electronic solutions to MRI scanning, and the DISPERSE project succeeded in removing many of these limitations. Well, the total investment in the project was about 10.7 million euros, and there was a really specialized group of participants which actually contributed to the success of DISPERSE, and you can see all the logos of those participants in the consortium on the screen. Now, ladies and gentlemen, of course, I would like to switch to the proud project coordinator from Philips Healthcare named Mark van Helvoort, and he will explain to us how the results of DISPERSE will influence the MRI examination of patients with multiple implants. I would say, Mark, the floor is yours.
Thank you, Charlotte, for your kind introduction. Indeed, I'm very proud to stand here and to share the achievements of the DISPERSE project with the audience. In turn, I would like to introduce my son to you. This picture of him was taken in the University Medical Center of Utrecht at the age of 4, some 15 years ago. He is epileptic and standard treatment with pharmaceuticals does not work. In Utrecht, they assess if brain surgery is an option. Here he is undergoing an EEG to measure the electrical signals from his brain. This is not enough, because also an image of his brain is needed. Therefore, he is referred to magnetic resonance imaging. Magnetic resonance imaging, or MRI, is a large piece of equipment which is particularly useful for imaging soft tissue. Over the last 30 years, it has evolved to the golden standard for neuroimaging, which is depicting the brain and the spine. In contrast to X-ray and CT, it does not use ionizing radiation, but employs large magnetic and radio frequency fields. In case of my son, it turned out that surgery was not an option. Fortunately, active implantable medical devices, shortly implants, were emerging. We decided that our son would participate in a clinical trial for implanting a vagus nerve stimulator. This implant is connected to the left vagus nerve in the neck and continuously delivers electrical pulses to the brain. So, statistically not proven, we believe that the implant worked very well for our son. However, we found out that further diagnosis became problematic. MRI was contraindicated because the large fields could damage the implant and it even could harm our son because the implant lead acts as an antenna for the RF field and can heat up the surrounding tissue. Of course, doctors, MRI manufacturers and implant vendors throughout the world are aware of this problem. Actually, it caused doctors to be reluctant to implant these devices, and it is only a very last resort when everything else failed. Both from a medical and an economical point of view, we needed to change this situation. We, as electronics industry, need to create implants which can coexist with MRI. This is only possible through collaborative innovation projects and joint standardization activities. At the start of DISPERSE, technology was available to scan patients with one implant at the cost of examination time. With an increase of the use of implants, the number of patients with more than one implant becomes significant. If you think this is rather far-fetched, I would like to introduce you to Simon Schaefer. Until he was 6 years old, Simon was nearly deaf. His hearing was restored with a cochlear implant on the left side. At the age of 12, he received a second implant on the right. With 2 implants, he is able to also hear in noisy environments like restaurants. This enables him to fulfill his dream to study at a regular university. Currently, at the age of 26, he is studying at the Karlsruhe Institute of Technology and has a part-time job at IBM. In addition to tackle the challenge for multiple implants, we developed electronics allowing faster MRI scanning. To improve MRI sensor technology, we joined forces with the Netherlands Institute for Radio Astronomy. They are working on new architectures to replace these huge disc-like antennas by arrays of much smaller antennas. With this technology, MRI will be able to scan patients with implants as fast as regular patients. Concrete, DISPERSE delivered miniaturized and power-efficient RF receive electronics and communication photonics. I would like to conclude the achievement section of this presentation with David Mzi. David was a student and athlete back in 2010. He broke his neck when jumping off a trampoline, and he was told he would never be able to walk again. Thanks to the groundbreaking work of Professor Grégoire Courtine at EPFL and a multi-electrode implant lead developed by DISPERSE, he is now able to walk again. The great results achieved by the DISPERSE project would not have been possible without a great team. I would like to thank all participants for making dreams come true. Of course, I would also like to thank the national public authorities and the PENTA program office in supporting us throughout the project. To conclude my presentation, I would like to recapitulate that the ENIAC project DENICOR delivered technology to scan patients with 1 implant. DISPERSE strongly reduces the examination time and allows patients with multiple implants. And next year, the PAVUS project will start, and PAVUS will embed artificial intelligence directly into MRI and implants to personalize diagnosis and treatment. Thank you for your attendance.
Thank you so much, Mark, for your kind presentation. Also good to see that you will have a follow-up project. And wow, this really is a healthcare success story and also a very unique personal story, I would say. And that you enable people within this project, at least also young people, to give them a proper future. And what's also very nice is that you managed with this project to really concretely show the impact on society and the impact on citizens' lives. And I also have a question related to that for you, Mark. And that is actually, well, the DISPERSE technologies are now very much limited to the healthcare field, but can they also be applied to other domains?
Thank you, Charles, for asking if the technology developed by DISPERSE are also applicable outside the healthcare section. And actually, within the project already, we brought together 3 application areas. Next to healthcare, we had radio astronomy, and we had smart cities. And in the smart city application, we developed arrays of sound cameras which can detect street violence, such as shouting and gunshots.
Okay, thank you very much, and the best of luck in your project and the successor project. And ladies and gentlemen, of course, I'd like to hand over also to the proud PENTA director. I'm sure he's very proud of this, and that is Peter Connock. And well, we are here virtually, but I know you are going to hand over that award to Mark. So Peter, I'd like to give the floor to you for your kind remarks.
Yes, thank you. Certainly proud. 2020's turning into a pretty good year for PENTA. We've just launched our latest call yesterday with Euripides, and now we are seeing the results of our very first projects that started 4 or 5 years ago with this DISPERSE success. So I really am delighted to have the opportunity to present this first PENTA Innovation Award. As we know, all of these projects are designed to stimulate collaboration, push the state of the art, and really begin a new generation of technology. And but there has also to be impact. There needs to be economic impact, and also, wherever possible or wherever appropriate, societal impact. And as I think we've all just heard, DISPERSE ticks all the boxes. In essence, the MRI is a vital tool in healthcare for the aging society and the challenges faced by multiple implants, as Mark has demonstrated. But not only has that core area of the project been successful, but as Mark just said in the question, the technology can be used in broader applications as well, in space communications, in smart city safety. And there will be more, I think, that can come out of this project as it develops its exploitation plan. So all in all, it ticks all the boxes. It's an absolute deserving winner of the first Innovation Award. And with that, on behalf of PENTA, I'd like to, by the magic of the cloud, present the PENTA Innovation Award. There it is. It's appeared with Mark to the DISPERSE team, with Mark accepting it as project leader on behalf of the entire team. Thank you very much. And I hope we can also have a virtual round of applause.
Of course, thank you so much. And I'm going to give you an applause for sure. So thank you so much. Mark, do you have a final word for Peter?
Yes, of course. I would like to thank Peter and his team again for all the support they gave. I was very proud to be the piloting project. We were the first project to start, and we were the first project to end. Every other first project to end to receive this very nice award. And as Charlotte already said that in the introduction, I am very proud and particularly at my great team. Since this project it has to end, of course, but we will meet each other in other projects and other times and continue the success. See you again, and thank you.
Thanks a lot, and the best of luck, and make sure you don't drop the award. Thanks a lot. So, ladies and gentlemen, we're now switching to the next award winner, and this is the project Mnemosene, and this project started in January 2018 and is part of Horizon 2020, the European Union's Research and Innovation Framework Programme. The purpose of the project is to address major limitations of today's computing architectures and technologies used to implement them. This is done by developing new computing engines being able to enable cost-effective computation of currently infeasible edge applications fueling important societal changes, including personalized health, drones, smart environments, smart robots, and so on and so forth. The European Union's investment in the project is about 4 million euros. And as you can see on the slide, there will be, or there have been so far, a project consortium of 9 different partners from 7 different European countries. And now I'd like to switch to the proud project coordinator, Professor Dr. Said Hamdioui from the TU Delft, who will explain the results to us and the importance for the European positioning in this technology area. So Professor Hamdioui, I'd like to give the floor to you and hand over to you.
Thank you, Charlotte, for the introductions. Good morning, everybody. I will use the next 5 minutes to introduce you to Mnemosene and show you how this project sets a strong step towards low power or green edge computing. So let's start first with the opportunity. So as you can see on the left side picture, the number of Internet of Things, IoT connected devices are increasing or is increasing. It will reach 80 billion in 2025. Connected IoT combined with edge computing, as you see on the picture on the right side, provide a unique business opportunity. Edge computing means doing computing and extracting the information locally where the data is generated, which means not sending the data to the cloud to extract the information. Think about deploying intelligence at the edge in a personalized healthcare wearable device, for example. But this kind of computing has specific requirements, as you can see on the slide. I will pick just one. That's the energy constraint. the energy budget is very limited. A device, for instance, should operate based on a battery. So now let's take a look at the energy distribution in today's computing engines. The picture shows a simplistic view on a conventional computer consisting of a processing unit called CPU and a memory where the data is stored. Let's use a simple operation, A plus B, to illustrate how it works. To do A plus B, I will need to move the A from the memory to the CPU, move B again from the memory to the CPU, and do the addition, and actually finally bring S back to the memory. If I would do the same thing C plus D, I would do the same thing again, data movement. You can clearly see that, okay, you can clearly see that we have to do with a lot of data movement. The question is now, how much energy consumes this data movement as compared with the actual computing? On the table, you see that the actual computing, which is done by the processing unit, consumes 0.05 picojoule. Let's say 1 energy unit. Data movement of chip in this case consumes 6.4 thousand times more energy. And clearly, you are interested in computing and not in data movement. So you can clearly see that we need new architectures if we really want to reduce the energy consumption. Another equally important aspect is that related to the technologies used to implement such architectures. They are volatile, meaning they waste the energy called leakage power, as you can see on the figure on the right. Even if there is no activity, you are losing the energy. Dynamic power is what we actually consume when we are performing actions. So the figure clearly shows that the leakage power increases as the technology node decreases, reaching unacceptable levels. More than 50% of the total power for 20 nanometer technology will be consumed as leakage power. Meaning, in fact, that we are wasting more energy than what we are spending on actual computing. Again, this is not acceptable. Therefore, we need new technology devices if we want to save the energy. So in conclusion, we need newer architectures implemented using new device technologies. And that's exactly the purpose of our project. Our project explores alternative architectures in the life of emerging non-volatile devices. Let me again use the same picture we saw before to illustrate how the computing will be different. So, and again, I will use the same operation, A plus B. So in that case now, what we will do, I will do the computing inside the memory. Rather than moving the data to the CPU, I will do the computing inside the memory. Hence the term computation in memory. Moreover, this architecture allows me to do parallel operations again within the memory and without moving data back and forth. You can clearly see that same architecture significantly reduces data movement and enables parallel computing. Moreover, actually, we are using emerging memoristic devices to implement such architectures. And emerging memoristic devices, they are non-volatile, which means that their leakage is practically zero. Combining these two concepts, same with emerging technology devices, we are aiming at improving the energy efficiency and the performance efficiency with a factor 10 times to 100 times better. Well, let's see if this is a dream or a reality. In partnership with our collaborators, and in that case specifically IPN, we manufactured a small chip, as you can see on the picture on the left side, with performed measurements, and we used extracted information to build accurate circuit simulator. We did experiments with a database consisting of 303 patients, and featured with 41 attributes or heart diseases. We choose an example of a query consisting of 11 consecutive operations. What we found, that we can perform 11 steps in no more than 36 nanoseconds. What does it mean actually? We can perform almost 100 giga operations per second. And giga operations, giga means 1,000 millions. So we are talking about 100,000 million operations per second. What about the energy? The total energy we spend to do this 11 step is 1 picojoule. And a pico is 1 from a trillion. And in terms of the energy per operation, we are talking about 6 femtojoule. And what is a femtojoule? Is 1 from a quadrillion. And is exactly the figures and the numbers and the order of magnitudes we need for edge computing and for deploying intelligence at the edge. And we heard this morning and also yesterday the importance and the must of having edge computing. So finally, how does this actually position Europe? First, it will enable, the Mnemosene will enable economically affordable solutions, being able to bring intelligence to edge applications and battery-driven devices. Number two, it will set up an important step towards neuromorphic computing, in which computational memory is essential to mimic the brain. And last but not least, it will put Europe in a leading position when it comes to emerging computing paradigms using unconventional technologies. So thanks for European Commission and for H2020 for sponsoring these projects, even after we tried it 3 or 4 times. And finally, I would like also to thank the partners for the outstanding job in order to realize our achievements. And thank you for the audience and for listening. Thank you.
Wonderful contribution, Professor Hamdioui. And as you pointed out, we need these kind of new architectures in order to reduce energy consumption. And ladies and gentlemen, we do have an answer, because Mnemosene is your answer. And I also see a lot of links, for example, where you said, Professor Hamdioui, is that this edge computing is very important. What we've seen this morning already is that it is definitely one of the key priorities also within the broader strategic research and innovation agenda of the ECS community. One question for you, Professor Hamdioui, and that is basically, what does the use of AI mean for future computational technologies?
So thank you, Charlotte, for the question. Actually, we do believe that if we're gonna make use of artificial intelligence, as we know, AI, artificial intelligence, is changing the way we are actually living our daily life. And it has been already in wide use, think about, especially in the big machines in the cloud. Think about Google, Facebook, etc. And if we really wanted to deploy this intelligence at the edge, close to people, think about a personalized healthcare, when we're going to deploy wearable devices equipped with intelligence. In this case, we can only do that if we are able to develop ultra low power computing engines, for instance, which can operate, as you already mentioned, on a battery. And this is where you really need this kind of architectures in memory computing as one of the potential alternatives. And we do see, and we strongly believe that Mnemosene, or the concepts developed in Mnemosene, can strongly help in bringing intelligence and artificial intelligence close to the edge, which is not there yet today, especially for applications which have extremely low budget constraint when it comes to energy consumption.
Okay, wonderful. And I can definitely see, Mr. Hamdioui, you're very convinced about the solutions that your project offers as well as your colleagues. But I also would like to turn to the European Commission, because they thought it was very convincing as well. And it is my great honor to introduce to you Nick Catavinos, who is the Policy Officer for the Competitive and Electronics Industry at DG Connect, also a colleague of Paco, whom you've seen already earlier today. So Nick, you also must be a very proud person right now.
Indeed. Thank you, Charlotte. You can hear me, okay?
Yes, I can.
Great. Good morning, everybody. Indeed, and I'm very happy to be in this position today to represent the Commission in handing over the Horizon 2020 Innovation Award under the Efecs event. And for this, I would like to thank Professor Hamdioui for this excellent and clear presentation. And indeed, I can only just repeat that coincidentally, this project actually covers many of the topics that we've been discussing since yesterday, also for the upcoming framework program that we're supporting in research and innovation in terms of computing at the edge, processing, AI, low power, greener technologies. And for this, I'm very happy that Mnemosene was the winner this year. I must say that just to repeat a bit of what Peter Connick already said, in these projects, it's only evident when you look at the partners involved that we have clear evidence that the technology developers are there and it's going to be a success. But this can only be done by collaborative projects. And I think this is an extra element that we bring by providing the EU funds to these partnerships. And so thank you also to Professor Hamdioui for trying, as he said, a few times before reaching here. And we're very happy for the project results and the success. I must say that we go through this process every year for the award, and we do receive a lot of applications and some very excellent projects. And for this, it's only fair to actually mention that we did have 2 runner-up projects from different fields, one on health, which was Madia, and one on the micro OLED, which was Milady. So congratulations to them too. They came close, but of course, there can only be one winner. And for this, it is my honor to, on behalf of the Commission, on behalf of DG Connect and Directorate A, to hand over the Horizon 2020 Most Innovative Project to Mnemosene. Congratulations once again.
Thanks a lot. And I think, Professor Hamdioui, could you keep it up a little bit higher so we can even see it better? Yes, perfect. Thanks. Lovely to see. Do you have a final remark or comment for Nick, Professor Hamdioui?
Now, we would like to thank again the European Commission and H2020 program for funding and supporting this project. And we are also extremely happy to see that these topics are also included in the upcoming programs. We heard a lot about edge computing, AI at the edge, ultra-low power, green, etc. These are all terms that comes closely to our research interests. And I will say just expect new projects in this direction. We will follow our project in this direction. Thanks a lot.
Thanks also for your kind words and the best of luck with the follow-up of the project. Thanks. So, ladies and gentlemen, yes, exactly. Thanks. We're going to switch now to the final Pioneer Award awarded by the ECSEL Joint Undertaking. And this year the award goes to Taranto, and the award has been extended beyond projects that excel in dissemination to also include those that have shown exceptional technological advances. And therefore Taranto has been selected. Taranto started in April 2017 and aims at strengthening the leading position of the European semiconductor industry. The technologies developed by Taranto provides a solid industrial base for the development of new products in areas such as telecommunications, industrial, personal and car electronics, which are of key importance to Europe's high-tech industries. The ECSEL's investment in the project is, ladies and gentlemen, 43 million euros. So that sounds very promising in terms of budget. But also if you look at the project consortium, they consist of a total of 32 participating organizations. And those are the main European players in the complete value chain, from universities and laboratories to industrial users located in 6 different countries. And now we are going to watch a video which has been produced also kindly by the project leader, I would say, Pierre, Jerome, Goirand from ST Microelectronics. And if we can please put the video on the screen, that would be wonderful.
Thank you, Charlotte, for this introduction. Great thanks to the ECSEL organization to offer this great opportunity to the Taranto Consortium to present the Taranto project. Taranto was started to solve challenges in telecom speeds brought by 5G and in detection precision of radars brought by autonomous vehicles and robotics. 5G's deployment requires 10 times greater data speeds due to volumes to be transferred, like for videos, and to the multiplication of data sources due to ubiquitous fixed or onboard sensors. Autonomous vehicles and robots requires radar's detection precision to improve by a factor of 10. To enable these, Taranto's objectives are to develop BiCMOS silicon semiconductor technologies, targeting to reach 50% better speeds and power efficiency, and integrated circuits and systems for more efficient telecommunications and radars for safer roads and public spaces. To meet these challenges, European industrial leaders in telecommunications and radar detection systems, such as Nokia, STMicroelectronics, Infineon, SIAE, have joined forces with a total of 32 highly motivated partners, having demonstrated great collaboration in previous projects. They represent the complete value chain for the realization of the demonstrators of systems and thus allow the expansion of a remarkable European ecosystem in BiCMOS technologies. While the competitive positions of the partners stay, this collaboration strengthens their leadership and sovereignty of Europe. This demand for speed and reduced power consumption by the telecommunications and radar industries poses enormous challenges to semiconductor manufacturers. The best positioned to overcome them are the world leaders in BiCMOS technologies, STMicroelectronics, Infineon, and AHP. Their new technologies, developed in Taranto, set new state-of-the-art levels with speeds at 700 GHz, thus 50% higher, obtained by AHP for small series, and currently 495 GHz, thus 25% faster by Infineon, and soon plus 50% by Infineon and STMicroelectronics for mass production. For the sake of instantaneous information availability from the cloud to your smartphones, the speed of optical fiber links must increase endlessly. A new step has been taken in Taranto with a tremendous world record in speed at 1.52 TB per second over 80 kilometers. To help 5G deployment, costly optical fiber installation can be replaced by lighter wireless beams with very high speed, which are developed in Taranto, like the 5G wireless repeaters to deliver internet access to homes, and the 5G wireless data hauling system for connection to the core optical fiber network. A 6G precursor transceiver is currently developed in Taranto. Taranto develops radar systems with millimeter positioning accuracy to improve the control of moving robots in large storage facilities, then to enhance the connectionability of your smartphones to home devices with compact radars having half a watt consumption, and finally to enable new applications such as the evaluation of health vital constants or indoor spaces observation with a pulse radar having low transmit energy milliwatt consumption, very low cost. Taranto has enabled STMicroelectronics, Infineon, and AHP to reach a fantastic position with the new BiCMOS technologies. When the industrialization will be soon finished, this level of speed and energy efficiency will not be found anywhere else in the world. With the tremendous traction resulting from the world record in speed for optical telecommunications held by Nokia and Micram, Taranto is enabling outstanding new products to emerge. Highly innovative 5G and even 6G wireless systems will be industrialized by Nokia, Infineon, and SIAE. Taranto largely widened the domains of radar utilizations with economical, efficient, and accurate solutions developed by Infineon, DICE, and INRS. To conclude, Taranto has provided a unique frame to competitors to become partners in a world-class and efficient collaborative ecosystem for BiCMOS technologies. And this is key to maintain their world-leading positions. Through these leading positions in key technologies and systems, Taranto also enables Europe's sovereignty reinforcement on data control. Taranto's tremendous achievements in telecommunication systems will enable reduced energy consumption and healthier environments with more directional wireless beams. The outstanding results obtained in radar systems are essential to improve road safety, security in public spaces, homes and vehicles, and benefit the industrial and health sectors. On behalf of the Taranto Consortium, I greatly thank the European Union national public authorities and professional organizations for their
It's a kind video, and it definitely shows the excellence that you display within this project. And well, ladies and gentlemen, yesterday already talked about how to put Europe in a leading position. And my question would be also to Mr. Goirand, is you mentioned that this technology development in Taranto actually puts Europe in the lead. So I was just wondering, what does it take to make sure that Europe keeps this position? I'd like to give the floor to you.
Yes, thank you, Charlotte. Indeed, this is a good question, how to stay in the lead. So as we saw in the video, Taranto performed very well, and not only because of the fundings, even if this is important. What made competitors like Infineon and ST collaborate in this unique frame provided by ECSEL is that expert partners such as research organizations and also academic and university labs that help them to develop the technologies and also help them to show the tremendous results of these technologies with the help of industrial and end users partners like Nokia and SIAE, for example, which build system demonstrators which show these outstanding performances. So in this frame, every partner has been a winner, in fact, and with the emergence of new products and new technologies. And to answer your question, what we need right now is to go for the industrialization phase. It's industrialize the systems and the technologies that Taranto has developed. And for this, we have, in fact, we have already submitted a new project in the ECSEL frame. So
okay,
for this question.
Thanks for this contribution. So I think it's very much in line with what was discussed yesterday as well, is that of course the funding is very important, but then also the collaboration. What's so nice about these kind of projects, such as this ECSEL project, is that the basis of this is collaboration within a wider ecosystem of industry and academia. So thanks a lot for that. And I'd like to switch to Anton Chikov, who is the program officer of ECSEL. And I am very pleased to give you the floor, because we're also happy to hear from you, your vision and view and comments on this project, Taranto.
Thank you, Charlotte. Well, one of the main objectives of ECSEL is to make the European ECS ecosystem competitive. And in this sense, the selection of ECSEL fell to Taranto because they have made the fastest HBTs in the world, and in addition, managed to build them into a very high density CMOS process. At this moment, it is as fast and as dense as you can get. With these accomplishments, the project has propelled Europe into a pole position in this crucial technology. And why is it crucial? This new generation of HBTs will be a key factor in speed communications systems like 5G and later, as well as in the very dynamic field of connected, cooperative, and automated transport systems of the future. So with all this project has also drawn international attention and has been recognized as a breakthrough. And as a consequence, some of the other regions are hurrying up to put money into similar projects to try to catch up with Taranto. So you can imagine we are very happy and very pleased with what Taranto has achieved. So at the end, I have to say it has been a pleasure to work with this consortium. They have managed to create a very good team spirit, although they are from different companies and sometimes competitive companies. But more importantly, they are very dynamic, very professional, and very accurate in the execution of the project. So I would like to thank again the whole team and congratulate them with this award. And it is my pleasure on behalf of ECSEL JU to hand this award to Taranto. The award is yours.
Thanks a lot, Mr. Chikov. And indeed, I can see a very proud Mr. Goirand as well with his award. And how nice that apart from the awards, you really have this worldwide recognition. What more can you ask for? Perhaps, Mr. Goirand, do you have a final closing word? Anything you would like to say to Mr. Chikov?
Yeah, sure. Anton has been very good in describing the project spirit and the consortium spirit. Very nice people, very professional, very accurate, very available, very flexible also. So I thank Anton, but I think the whole Taranto team as well. And we hope to go on with a further project with the next phase.
Okay.
It's really a big hope. So thank you again, Charlotte and Anton.
Thanks a lot, and also for you, the best of luck, and keep up the good work within your project. So, ladies and gentlemen, of this specific award session, and what's so nice about that and this whole event is that we manage, with the help of you and with the support of all the people from the European Commission, but also from the member states and from industry, to have a broader overview of what the ECS community can do, not only the abstract level, the policy, but also how this really translates into very concrete and excellent projects. And we're not finished yet, because now, ladies and gentlemen, you have the opportunity to join some parallel sessions to discuss even into more detail some components of the strategic research and innovation agenda for the electronic components and systems industry. And those 3 sessions are the so-called lighthouses. And there's a lighthouse on mobility, there's a lighthouse on industry, and there's a lighthouse on health. So you're more than welcome to log on there, and I'd like to welcome you back at 1 o'clock for a final word to you. So thanks once again, enjoy the sessions, and we see each other later.